All right, so that's what the empirical rule is telling us. 68% of the data lies within 1 standard deviation above and below the mean. 95% of the data lies within 2 standard deviations above and below the mean. And then lastly, 99.7% of the observations fall within 3 standard deviations above and below the mean. Okay? So here's the deal. Besides, the reason why I'm bouncing back and forth between these two is because I think visually it helps you to see the empirical rule on the top page where you see that 68, 95, 99.7. But we also we need to figure out what that means for each individual slice here. Like this slice and this slice and this little slice here and this little slice here. So we need to think about and figure out what each of, yeah, that one's not showing up. I got a nice pretty orange, but it's not really showing up. And then this last little bit here, what percent of the data is there? So we need to think about each individual slice as well, okay? So that's what we're gonna look at and talk about. If we're told that 68% of the observations fall in this interval right here, and it's basically broken into those 2 parts, 68 divided by 2 tells us that this slice right here is 34% of the data, and this slice right here is 34% of the data. Okay, so that's the first slices from the mean, 1 standard deviation out in both directions. 34% of the data is in each of those slices. Okay, guys, that's 1/3 of the data is in each of those. So 34 in each of those 2 slices added together gives us that 68%. Right? We're going to do a little bit of math so we can figure out what the green area slices are. So I want you to think about this.
Wait, shouldn't the green... Oh, the arrows are different than the squares.
Yeah, I've got my arrows. I'm doing wonky colors. I'm sorry. No, I need to try to be more consistent with that, but I'm not. So I'm glad you pointed that out. So I'm going to do this.
I was just making sure.
Okay, so the second part of the empirical rule, Ja, what does that say? The second part?
Where?
Up here.
Let's see. Which part?
The second line.
95% of observations fall
Within 2 standard deviations of the mean. Good. Okay. So that means from the mean, 2 standard deviations this direction. From the mean, 2 standard deviations that direction. So it's all of this right here. And if that whole amount is 95%, but the blue amount is 34%, to figure out the green amount, we need to subtract those 2. So 95, yikes. All right, Ireland. I'm just getting so excited that I'm writing things wrong. So 95 minus 68, if we do the math here, we find that these green sections have to equal, the 2 sections together have to equal 27%. So if we divide that by 2, there you go. What you find is that this particular area right there is 13.5% of the data, and this particular area right here is 13.5% of the data.
Oh, it's the same. Oh my god.
So it's the same on both sides, right? It has to be because we have a symmetric graph,
We're just confused.
right? Yeah, it has to be the same.
That makes more sense.
Okay. So I want you to think about this. This is saying that all together here, 2 standard deviations below to 2 standard deviations above. So this is 95% of the data. So that tells us we know, and we already kind of talked about this, that means together this and that has to be 5%, so we divide by 2. So I want you to think about the fact that out here at the ends, this is 2.5%. But we're going to be more precise and look at each individual of those slices also, because you've got to get those numbers memorized as well. I want you also to know and think about the fact that, guys, 95%, that's a huge chunk of the information there, from 2 standard deviations below to 2 standard deviations above. These are what would be considered usual observations or typical observations. It means these from 2 standard deviations from the mean all the way out in each direction, these are considered unusual. Anything beyond, I can't spell, unusual, I have an extra A in there. I'm just getting so excited to talk about this that I'm making careless mistakes, and I apologize. So unusual, because it's beyond these the 2 standard deviations from the mean. So it's a very small amount of the data, okay? But we do want to figure out what those little, each individuals of these slices is also, okay? So let's do the math. For the third part of the empirical rule, it says 99.7% lies within 3 standard deviations from the mean in each direction. So if we do 99.7 minus 95, we find that we get 4.7. And if we divide that by 2, we get that this little part is 2.35%. So that means this little part is 2.35%. So if you do 2.5 minus 2.35, what you find is this little blip at each end of these graphs is 0.15%. So this little blip is 0.15%. So besides these numbers of 68, 95, 99.7 that you need to memorize, you also need to memorize these slices, what I refer to as the slices. You need to memorize the 34, the 13.5, the 2.35, and that 0.15. Okay? All right, questions? No? Okay, does that make sense where we got those numbers from? And you're just going to memorize those. 34, 13.5, 2.35, and 0.15. Now I'm going to show you how we actually use those. Okay? So onward. All right, there's our pretty little multicolored 68, 95, 99.7. But let's look at this example, and we're going to kind of talk through some examples here to help you see how you use this, how you apply that information. Okay.
Yeah, I hear it.
No, you should not be able to. We're going to write some new numbers there. Okay, so according to the Health and Nutrition Examination Study of 1976 to 1980, the heights in inches of adult men aged 18 to 24 are, and then this, you look at that and you're like, what in the heck does this mean? So I've got to tell you a little bit about that notation first. So the capital N is telling us that we are dealing with a normal distribution.
Is the 70 the average and then the 2.8 is the standard deviation?
There you go, Alex, perfect. So the 70 is our mean, and our standard deviation is that 2.8. That's what that means, okay? So 70 is our mean, 2.8 is our standard deviation. So we're going to use that information in order to draw in the numbers that we need here, that you guys were like, I can't read these numbers. It's okay, because I didn't want you to read those numbers. Our mean is 70, so that's right smack dab in the middle here. Our standard deviation of 2.8 means we're going to repeatedly add, we're going to take 70, we're going to add 2.8, so 72.8. And we're going to add 2.8 again, so we get 75.6. And then add 2.8 again, and we get 78.4. So that's progressing in the positive direction. We also need to take 70. We need to subtract 2.8, so we get 67.2. Subtract 2.8 again and get 64.4. Subtract 2.8 again, and we get 61.6. So when you see a problem where you're given this information, you are going to have to label all of this stuff right here. Okay? We are not going to be concerned about making sure that our spacing is just right in terms of the size of those standard deviations like you learned on Friday. Okay? We're going to focus our attention on this type of problem, on making sure we understand we're going 1 and 2 and 3 standard deviations. So you don't have to be quite so worried about that concept that I was showing you on Friday. All right, let's see how this works though. So first question, it says, what proportion of men are less than 67.2 inches tall? So think about what that's saying. Less than 67.2 inches tall. So that's saying from here and lower. And we want to figure out what percent of values or proportion of values are in that region, in that area. Okay, we can do a 100 minus, but be careful about what we're 100 minusing. So you're right, this is 68.
But then you have to add up your
We got to add those other parts also. So we can do a 100 minus in order to figure this out. But,
13 plus 2.5.
yeah, I think it's probably faster and easier in this case. This slice right here
Add 1.5 or no?
is 13, yep, 13.5. And then you could think of it as the two parts together or separately. This is 2.5. So if we add those together, 2.5 plus 13.5, we're going to get 16%. Does that make sense? Okay. We'll look at some where we're going to do some subtraction. So I like that you mentioned that, Megan. Okay, let's look at the next one. Okay. What proportion of men are less than 75.6 inches tall? So this is one where, yeah, if you're looking, yeah. Subtraction's going to be easier because we're going from here all the way over here. So it's going to be easier to actually figure out what's this amount and then subtract it from 100. So what is this amount over here? That part's, yeah, that part's just 2.5. So 100 minus 2.5. So 97.5%. Nice. And then, yeah, the next question, if you notice, is asking what proportion of men are greater than that. So that was the part that we figured out to begin with. Okay. All right, take a look at that question so far. Okay, this last question is saying, what proportion of men are between 67.2 and 75.6? So we're looking at this part that I'm shading right here. So from 67.2 up to here. So there's kind of a few ways of thinking through that one. Alex and Mason, you were both saying something. Alex, what's your?
81.5.
How did you get that?
I just did 68 plus 13.5.
Okay, so 68, so that's this part,
Yeah.
plus 13.5, that's this area there. And so you get 81.5. Yep, that works. Okay. All right, questions. The idea at this point, I've got a worksheet for you just to kind of give you some help and practice with kind of the whole process. Yep.